So yesterday what we did was we had melting points ka main sara, we discussed all of that, and we discussed electricity conduction. And now what we're going to do is we're going to talk about the reactions with water. So I'm going to talk about the first one, which is sodium. You all know that sodium reacts very vigorously with water. So it's got a very vigorous reaction. It forms a very strong alkali, and it's a vigorous reaction. और इसमें याद रखना कि sodium is low density, so it floats and fizzes on the top surface. So floats and fizzes on the surface. Plus, there's going to be hydrogen gas that is going to be produced whenever there's a gas being produced, so that is going to be bubbles or effervescence. There's going to be effervescence produced. So ये थोड़ी बहुत, I've added Rani, I think. I said, then you have magnesium with water. Remember, magnesium with water that happens at high temperatures. And at high temperatures, it's a reaction that happens at high temperatures, usually with steam. So इसी का ना एक दूसरा reaction है, which is you could also state that Mg reacts with steam. And when Mg reacts with steam, it forms MgO plus H2. एक चीज याद रखिए कि remember one thing, that hydroxides and oxides are kind of the same thing. So MgO is a white solid. So when it reacts with steam, and this is steam, the reactivity is lesser. You've got Na is very reactive, Mg is less reactive, so it requires high temperatures. The reaction is kind of the same, lekin agar bahut high temperatures, if you use very high temperatures, then water would be in the form of steam, and the hydroxide would instead be an oxide. And also remember this, hydroxides, they change into oxides if the temperature is really high. Otherwise, oxides and hydroxides are kind of the same thing. But at high temperatures, you usually have oxides. Pani ke andar mix karo, you get hydroxides. And the reason a weak alkali is formed is that magnesium hydroxide, if it forms, it's not very soluble. So it is not very soluble, which is why it's going to be a very weak alkali. It's not going to mix with the water, and it's not going to ionize with the water. So very few OH ions are actually going to be produced because it's not going to mix with water. NaOH, on the other hand, is very soluble, which is why it's going to be a strong alkali. So I'm just going to sum this up. Sodium, a vigorous reaction. It's a group 1. You got NaOH, H2. NaOH is very soluble. You get a very strong alkali, and it's a vigorous reaction. Mg with water, it's either a very, very slow reaction, or it goes and reacts with steam at high temperatures. And if it mixes with water, it's not really going to mix with water a lot. A very weak alkali is going to be formed. Ye clear hai dono ka? Is this clear?
Sir, could you repeat it?
I mean, this thing that sodium reacts vigorously with water, Mg reacts very slowly with water and reacts at high temperatures because Mg is less reactive. I mean, that part or which part?
Yes, thank you.
And also remember the pH of the alkalis that are formed. This is very soluble. This is not soluble. It's not soluble, so it's not going to mix with water, so it's not going to be a very strong alkali. The others are not going to react with water. Aluminium specifically, you studied in O levels, it's got a non-porous, unreactive Al2O3 coating on it. You've already done this many times in O levels. Chlorine, you mix it in water, and chlorine is usually used as a disinfectant in water. You've studied that in O levels as well. It's used as a disinfectant. And it produces two types of acids, chloric 1 acid and hydrochloric acid, HOCl and HCl. So you just have to remember this equation. Then we're going to talk about oxidation states. So oxidation states. Yes.
Sir, above you said that it will be a weak alkali, right? So will it be a weak base as well?
No, not a weak base. बस वो पानी का जो pH होगा ना, I mean, it's not going to change the pH of water.
Oh, okay.
ठीक है, so it's going to be a weak alkali. I mean, the pH would be around, you can say 8. जबकि NaOH का pH would be around very close to 14. It's going to be very strong. Like it's going to mix with water. ठीक है? So when we use the term alkali, what we mean is how much is it going to mix with water, and how many OH ions will it produce when you mix it with water.
Okay.
Achha, oxidation states quickly. You already know that in NaMgAl, they are +1, +2, +3. Non-metals have multiple oxidation states. They can have many oxidation states. These are the common ones. Phosphorus can be +3, +5. Sulfur can be +4, +6, like SO2, SO3. Phosphorus can be PCl5. It could also be PCl3. Phosphorus could have two oxides, P4O10 or P4O6 as well. So non-metals have multiple oxidation states. The same goes for Cl. You could have NaCl, you could have NaClO, you could have NaClO3. So lots of multiple oxidation states for chlorine as well. And these are not the only ones, these are the ones that are common. Sulfur ki mostly +4, +6, but it could have other oxidation states as well.
So why does it have many oxidation states?
What?
Why does it have many oxidation states?
Because for non-metals, the way you calculate oxidation states, I mean, like if I talk about sulfur, right? The way we calculate oxidation states is based on the electron, because non-metals, they form covalent compounds, right? So in covalent compounds, they're not actually losing or gaining electrons. What is happening is one of the elements is electronegative, the other one is less electronegative. In this case, sulfur is more electronegative. So these electrons would be closer to sulfur, right? So that means if these electrons are closer to sulfur, you're gonna treat it as if it's ionic. This is going to be -2, and this is going to be, this one is going to be +1. Similarly, if sulfur is bonded to 6 fluorines, so if it is bonded to 6 fluorines, then all the electrons would be closer to fluorine, because fluorine is the one that's more electronegative. So that means sulfur in a way is losing 6 electrons, and sulfur will have an oxidation state of +6. So if I have, so now if I have SO3, so all the electrons, 6 electrons of sulfur would be closer to oxygen. So sulfur will again have an oxidation state of +6. So the point is, it all depends on the electronegativity difference, which is why the oxidation state is going to vary. Is that point clear?
Yes.
So sometimes they would be more electronegative compared to the other element. Sometimes they're going to be less electronegative compared to the other element. But when it comes to metals, metals are always losing electrons. They don't have a choice. They just lose electrons because they are always less electronegative compared to all the other non-metals. So they always lose electrons. So this is always going to be +1, +2, +3. So which is why they can have multiple oxidation states. And there's another reason for that as well. These are period 3 elements. Period 3 elements can expand the octet as well. Like any element that's period 3, its outer shell can have, just one second. So any element that's in period 3, its outer shell can have maximum 18 electrons. So if I write the electronic configuration of phosphorus with 15 electrons, its outer shell is 3s2, 3px1, 3py1, and 3pz1. So at the moment it needs 3 electrons, so it's going to make 3 bonds. But phosphorus has a 3D subshell as well that's completely empty. So what it can do is it can further distribute its electrons, like the 3s electron can further be distributed, and now it can form 5 bonds, each orbital getting pulled in a different direction. And phosphorus, instead of making 3 bonds, it can make 5 bonds with Cl. Let's say, for example, so it can distribute its electrons further, and it can bond with 5 Cls. So it can vary the number of bonds that it forms. Is that point clear as well?
No, sir, I don't understand this.
ये वाला देखो इसमें था कि मतलब this was known as Octet Expansion. We did this in chemical bonding as well. मुझे बताओ कि if you have a period 2 element like oxygen has a total of 8 electrons. Oxygen's outer shell is the second shell. Second shell has only these orbitals, 2px, 2py, and 2pz, and it's 2, 1, and 1. अब मुझे बताओ कि that's it. Oxygen just has, that's it. Those are the only orbitals oxygen has in the second shell. तो मुझे बताओ कि कितने orbitals को electrons चाहिए? इसको चाहिए और इसको चाहिए, right?
2 orbital.
तो oxygen will always form 2 bonds. मतलब और तो कोई orbital है ही नहीं, मतलब ये तो पहले ही fall है, right? और आगे तो कोई orbital नहीं है ना. Second shell में इतनी orbitals हैं. ये clear है बात?
Yes, sir.
तो ऑक्सीजन का जो शेल है ना उसके अंदर you can't expand its octet. अगर मैं सल्फर पे आ जाऊँ ना, जो period 3 है, सल्फर का जो the outer shell, it's got 16 electrons. If you write the electronic configuration, the outer shell would be 3s2 or 3px, 3py, and you've got 3pz, and it's going to be 2, 1, and 1. और फिर 3D आ जाएगा. ये मैंने 3D के ना सारे ये नाम नहीं पता होना चाहिए इनका, ठीक है? और and the thing is कि ये सारे खाली पड़े हुए हैं. All of these are empty, right? तो मुझे बताओ कि सल्फर अगर इलेक्ट्रॉन अट्रैक्ट करेगा, कितने इलेक्ट्रॉन्स अट्रैक्ट कर सकता है? इसको फिल अप करने की कोशिश करेगा,
2.
इसको फिल अप करने की कोशिश करेगा, लेकिन बाकी भी तो पूरे सारे खाली पड़े हुए हैं थर्ड शेल.
Oh, okay.
तो सल्फर कितने बॉन्ड्स बना सकता है? सल्फर खाली 2 इलेक्ट्रॉन्स अट्रैक्ट कर सकता है. मतलब दैट्स अ पॉसिबिलिटी, राइट? कि एक इलेक्ट्रॉन कहीं से पुल करके इधर ले आए, एक इधर ले आए. But it's got lots of other orbitals that are completely empty. The third shell is much bigger in size. So it has capacity to make more bonds. So what it can do is ये जो 2 electrons यहाँ पे इकट्ठे पड़े हुए ना, what it can do is it can further distribute those 2 electrons. एक इधर है, एक इधर है. One is over here, one is over here. So it can have a total of 6 orbitals that can be involved in bonding. तब भी 3 खाली रह जाएंगे. कि let's say एक fluorine के साथ bond कर रहा है. So one of the fluorine electron is getting pulled over here, one over here, one over here, one over here. So it can attract electrons from 6 fluorines. ठीक है? So sulfur has a much bigger outer shell, and it can increase the number of bonds it wants to make. Is that clear? ये clear है?
Yes.
ठीक है. ऑक्सीजन ये काम नहीं कर सकता था. ऑक्सीजन के पास बस ये खाली जगह थी, आगे कुछ भी नहीं था. आगे बस खत्म हो गया शेल, आगे कुछ भी नहीं है. ठीक है? तो ऑक्सीजन के पास तो बस यहाँ पे इलेक्ट्रॉन रख सकता है, या इट कैन पुट एन इलेक्ट्रॉन ओवर हियर. दैट्स इट. दोस आर द ओनली 2 places. And sulfur can even go on bonding, like it can form a dative bond with this one. Empty orbitals are used in dative bonding. So it can attract 2 electrons from some atom, 2 electrons from some atom, 2 electrons from another atom. Like usually it's very hard to make more than 6 bonds because of the spatial limitation. So is this clear? The idea that firstly, the reason why they have varying oxidation states is that sometimes these elements would be more electronegative, sometimes they're going to be less electronegative. So sometimes they're going to be +4, sometimes they're going to be +6, sometimes they're going to be -2. And the other reason is they can change the number of bonds they make, which is why the oxidation state would change as well. You could have PCl3, and at the same time, you could also have PCl5. Okay, is this clear?
Yes.
So next one is the reaction of their oxides with water. So you have to remember them. First one, sodium oxide. What sodium oxide does is it simply dissolves, that's it. And it forms a very strong alkali. I mean, all of them are kind of basically dissolving. This dissolves. MgO also dissolves, but it forms a weak alkali, so it's less soluble. So you have to remember the pH. MgO will not dissolve a lot in water. Aluminium oxide and silicon oxide are not soluble, so they're never going to dissolve. I said, then you have hydrolysis. This is known as hydrolysis. Phosphorus oxides and sulfur oxides, they don't just dissolve, they react with water, which is known as hydrolysis. So what happens is, if you dissolve P4O10, phosphoric acid is produced. If you dissolve P4O6, then H3PO3, which is phosphorus acid, is produced. If you dissolve SO3, you get sulfuric acid. If you dissolve SO2, you get sulfurous acid. तो इनके नाम याद रखना कि this is phosphoric acid, this is phosphorus acid, this is sulfuric acid, this is sulfurous acid. And you have to remember which oxide gives which acid. Uske oxygen, the more the oxygen, the greater would be the oxygen, the acid as well. So SO3 is going to make H2SO4, SO2 is going to make H2SO3. And during this hydrolysis, the oxidation state remains the same. Like over here, sulfur has an oxidation state of +4. So over here, sulfur still has an oxidation state of +4. In P4O10, the oxidation state of phosphorus, I think, is +5. And in P4O6, the oxidation state of phosphorus is +3. And it's maybe वही oxidation state होगी. This would be +5, this would be +3. But anyways, you just have to remember this. The first two, they dissolve. The first one dissolves very much and it forms a strong alkali. MgO doesn't really dissolve much. It's less soluble. It's almost insoluble. The pH is around 8 to 10. These two are not soluble, and the oxides of phosphorus and sulfur, they're acidic. So they end up forming acids. Is this clear?
Yes.
Yes.
अच्छा, अब अगला part है कि the reaction of chlorides with water. अच्छा, इसमें ये कि the first one dissolves. The first one just dissolves. That's it. NaCl, you know that. NaCl को पानी में mix करो, what happens? It just dissolves. That's it. And you get a completely neutral solution. The second one mostly dissolves. लेकिन थोड़ा बहुत ना hydrolysis भी होता है. When I say the term hydrolysis, that means a reaction with water. See, there's going to be a reaction with water. And AlCl3 is going to have a strong hydrolysis. It's not going to dissolve, it's going to have a very strong hydrolysis. So let me explain what's going on here. You've got AlCl3, MgCl2, NaCl. NaCl does not react, it dissolves. MgCl2 mostly dissolves, but some of it reacts and ends up producing hydroxide and HCl, and pH is slightly acidic because of the HCl. AlCl3, instead of dissolving, it mainly hydrolyzes. इसको मैं explain करने लगा हूं. Starting with NaCl. And I'm going to explain why NaCl does not react with water. So here's NaCl. When I mix it in water, it dissolves and the ions dissociate. So now, when Na+1 dissociates, ionizes, there is water molecules that are in the solution. And the water molecules are highly polar. And these very polar water molecules will get attracted to the Na+1 from all sides. So the water molecules will get attracted. The water molecules have lone pairs, and those lone pairs are going to get attracted to the Na+1 that's in the middle, that's floating around. Okay. Same happens with MgCl2. So I'm going to use the same beaker, and I'm going to change it to MgCl2, and there's going to be a third one, which is going to be AlCl3. So let's talk about Mg+2. Same thing happens. Mg has a +2 charge. कहाँ गया? अच्छा, गलत वाले को कर लिया. 1 second. So now the same thing happens to this one. And AlCl3 mixes in water and the same thing happens. It dissolves, right? So now here's a question. Forget the equation at the moment. How you Aisha, you have to memorize this. Okay, question though. अच्छा, इस पे आ जाते हैं. NaCl mixing in water, MgCl2 mixing in water, AlCl3 mixing in water. Now listen to this carefully. They all mix in water, they're soluble, they dissolve, and they dissociate into their ions. So the ions are floating around. You've got sodium ions, they're attracting the water molecules because the water molecules are polar. You've got magnesium ions, and they're also attracting the water molecules because water molecules, and the same thing happens to aluminium ions. अब मुझे बताओ, which one attracts the water molecules strongly, more strongly out of the
Al.
TK? So it's going to be Al, and the reason is that it's got a +3 charge. So that's a much higher positive charge. That means there's a lot stronger attraction. TK. So the reason why aluminium hydrolyzes is that aluminium has this extremely strong attraction for this oxygen because it's got a larger positive charge. And at the same time, in the case of aluminium, the hydrogen is going to be strongly repelled because the hydrogen is positive as well. So what happens is that the water molecules, they kind of break apart. Is that clear? The water molecules, they break apart, and aluminium ions, they attract the OH ions and they form AlOH3. So the water molecule has now broken apart. So let me just, so the OH, which is now -1, is going to be attracted, and the H+1 of the water is now being repelled. Is this point clear?
Yes.
So aluminum has a very strong hydrolysis, and a solid precipitate of aluminum hydroxide is produced, and a lot of H+1 ions are going to be released, and these H+1 ions are going to combine with the Cl ions to form HCl. So your solution is going to be highly acidic. So the solution that's going to be left is going to be highly acidic. Now, this thing doesn't happen in Na, because Na, it does attract the water molecules, but the attraction is not that strong. I mean, it does attract the oxygen, which is negative, and it does repel the hydrogen, which is positive, but the attraction and the charge density and the positive charge is not that strong that the water molecule doesn't get ionized. So which means the Na+1 is just floating around with the water molecule sticking to it. That's it. There's no reaction. Is that clear?
Yes, sir.
This one is the middle one. Like Mg is +2. So Mg +2 will only very slightly do that. Mg +2 has a higher charge. So sometimes these H will get repelled by and the O would get attracted. So sometimes the water molecule will get ionized, but there's going to be a very slight hydrolysis. That means most of the time this is not going to happen. Like in 1,000 molecules, some of them might get ionized, some of them, not all of them. So it's going to be a very weak hydrolysis. So these are the equations over here. Like NaCl just mixes with water, that's it. MgCl2, it mostly mixes with water, just very slight hydrolysis. There might be a very slight reaction in which MgOH2 solid would be produced because the Mg ions would attract the OH ions and the H+1 will get knocked out and they're going to produce HCl. And in the case of AlCl3, there's going to be a strong hydrolysis. And whenever you see this solid, there's going to be a white precipitate of a solid that's going to be formed. And a strongly acidic solution would be formed. Now, in the case of MgCl2, the acidic solution would be very weak because there's going to be very little HCl that's going to be formed. Is that clear?
Yes, sir.
ठीक है, is this clear to everyone? Anya, is this clear? By Aruba?
Yes, sir.
So, और ये कि now when you move across the period, the tendency to gain electrons, it just continues to increase. So silicon is becoming more electronegative. So uske baad hydrolysis becomes stronger. Like silicon is a non-metal, it wants to attract oxygen's lone pair. So there's going to be a strong hydrolysis. Phosphorus chlorides will also have a pretty strong hydrolysis. You have to remember these equations. Silicon chloride, it kind of has the same equation like aluminium. So that equation is almost the same. Silicon hydroxide. And remember, hydroxides and oxides can be interchangeably used. You can write Al2O3 over here instead of AlOH3. Similarly, over here, you can write SiO2 instead of SiOH4. And a strong acid would be produced. PCl3, PCl5, again, a strong hydrolysis, and you'll get two acids. P is going to form a phosphorus acid. Like if it's PCl3, it's going to form phosphorus acid. If it's PCl5, it's going to form phosphoric acid. And SiCl4, these have rapid reaction. Whenever you see HCl, remember this. Whenever you see HCl as a product, one of the observations that's always going to happen is you're going to see white fumes or misty fumes of HCl. Whether there's going to be white, smoky, misty fumes of HCl that are going to be produced. So on top of the beaker, you'll see these fumes coming out of them. Okay, just like in cold weather, you see the like if you have very cold water, there's this water vapors that you can see that are coming on top of the water, just like steam. Like if there's boiling water, there's white fumes of steam coming on top of it. So whenever these reactions take place, you'll see fumes of HCl that are forming. So these reactions, they need to be done in a fume cupboard because HCl fumes can blind you because they're acidic. So you have to remember all of these reactions. Remember, NaCl dissolves, weak hydrolysis, strong, and then it's strong hydrolysis. Sulfur chlorides are not in your course. I mean, sulfur chlorides, they don't normally they don't really exist that much, so they're not in your course. You just have to study till phosphorus chlorides. So we did two things: the reaction of oxides with water, reaction of chlorides with water, and the reaction of the metals with the water. Okay. So यहाँ पे I've written down the explanation as well for what's going on. Is that clear? एक मैं quickly चीज add कर दूं. Just one thing very quickly. This reaction over here, a lot of times the Markin scheme has this reaction for the aluminum reaction. This is the reaction, Al plus 3. First, it gets surrounded by 6 water molecules. And it forms Al with 6 H2Os. And then Al starts knocking out the H plus ones. So it becomes AlOH3 plus 3H plus 1. Sorry. So this is the same aluminum reaction. Sometimes they give this in the Markin scheme as well. But even the previous one that we wrote over here in the notes over here, where AlCl3 reacts with water and forms aluminum hydroxide and HCl, that's also fine. Or you can write the whole process that aluminum surrounds itself with water molecules and then starts knocking out the H plus 1 ions and ends up forming aluminum hydroxide. So you can remember this. We'll continue from here, TK, in the next class then, TK. Clear? Is there any question?
Sir, what did you say? For these P4O6 and for these AlCl3s and that the oxides that they form, the formula of the oxides instead of the hydroxides that they can
वो मैं कह रहा हूँ कि
while
remember
reacting.
hydroxides and oxides can be interchangeably used. Like if you write MgO over here, that's still fine. I mean, the equation is still fine. Remember, okay, all of these reactions, there are multiple different versions of these reactions, and they're all acceptable. जैसे यहाँ पे ना aluminium AlOH3 की जगह ना you can write Al2O3. That's still fine. SiOH4 की जगह you can write SiO2. So oxides and hydroxides can be interchangeably. They can be interchangeably used. तो आपकी equation भी different तरीके से balance होगी, but it will be still the same equation. Is that clear?
Yes, sir.
चल ठीक है, कल कंटिन्यू करते हैं.
Okay, sir.
Okay, take care. Allah Hafiz.